We've finally finished talking about the different types of microorganisms that can cause plant diseases. Now what I'd like to talk about are abiotic factors. These are non-biological sorts of things that can adversely affect plant growth and development. I usually group abiotic factors into four major groups. These include nutritional abnormalities, pesticide exposures, environmental pollutants, and adverse weather conditions. In terms of nutritional abnormalities, typically what we see are what we call nutritional deficiencies. This is where a plant has less of a particular nutrient than it really needs. And this is an example of a nutritional deficiency on poinsettia. Notice that there's a lot of yellowing on this leaf, but it's very uniform around the edge of the leaf. This sort of uniform characteristic to symptoms is oftentimes a clue that you're not dealing with a true disease, but some sort of abiotic issue with the plant. In this particular case, it is a nutritional deficiency, and oftentimes I ask students, what sort of nutritional deficiency do you think this is? One of the first things that comes to mind to most students is a nitrogen deficiency, because that will indeed cause a yellowing of plant tissue. Typically, though, with nitrogen deficiencies, it's a very uniform yellowing across the entire leaf, and it's typically on lower leaves. The other type of nutritional deficiency that students oftentimes guess for this particular slide is an iron deficiency. Again, a lack of iron in the plant will cause yellowing of the leaves, but usually where you see that is between the veins. So all of that interveinal tissue will be yellow, but the veins themselves will remain dark green. And where we oftentimes see this sort of nutritional deficiency is in oaks in Wisconsin. We have relatively high soil pH, and that tends to lock iron in the soil, so plants like oak can't take it up. And then what you end up with are these very distinctive interveinal yellowing symptoms on the leaves. In this particular case, the deficiency in the poinsettia is actually of a nutrient called molybdenum. This is what's called a micronutrient. It's one of those nutrients that you need just a little bit of, but not a lot. But it tends to be a real issue for poinsettia growers. So while you might not guess that's the problem with this particular plant, if you are a poinsettia producer, that might be one of the first nutrients that you would try to test for if you saw symptoms of this type. On the other end of the spectrum, you can also have nutrient toxicities. In this case, a grape leaf ivy that has this very speckled sort of look to the leaves. It almost looks like a mosaic symptom that you would expect from a viral pathogen, but in this case, it wasn't a virus that was the issue. As it turned out, this particular pattern of symptoms was due to copper toxicity. This plant was grown initially in a copper pot. There was enough dissolution of the copper from the pot into the soil that it led to some problems. So again, with nutritional abnormalities, you can have either end of the spectrum, too much of a nutrient in this particular case, too little of a nutrient. You can also have situations where you have nutrient imbalances, where two nutrients are well within their normal ranges, but their relative amounts are out of whack, and that can lead to issues as well. Kind of a common example of this is in corn production. If you get the nitrogen to potassium ratio out of whack too high, you can end up making the plants more susceptible to lodging or even stalk rot. I also tend to see a lot of issues with pesticide exposures. I think a lot of this is because people are more and more interested in having perfect lawns without any broadleaf weeds. And so folks are using a lot of herbicides in order to make sure these weeds are kept under control. And unfortunately, these herbicides can drift off of a lawn into a flower bed and cause some issues. The most common of the herbicides that are used for lawn care are what are called the growth regulator herbicides. These include herbicides such as 2,4-D and dicamba, and these particular herbicides mimic plant growth hormones. So the types of symptoms that they induce tend to be very odd growth patterns in the plants. In this slide, I have a picture of a geranium that was exposed to 2,4-D, and you can notice how cupped the leaves are. They're kind of fringy around the edge, and if you look at some of the petioles, they look kind of twisted. And all of these sorts of symptoms are very typical of an exposure to one of the growth regulator herbicides. If you're suspicious that you have herbicides drifting onto your property, consider planting some tomatoes along the lot line, because tomatoes are very sensitive to very low rates of growth regulator herbicides. You can see an example of this in this slide, a tomato plant that was exposed to 2,4-D, and you can see how the stems are curly-cued. You can also see some growth distortions in the leaves. Another great indicator plant, if you think you have herbicides around, is grape. When grapes are exposed to growth regulator herbicides, what tends to happen is the leaves get very fan-shaped. They tend to have fringed edges, and the veins in the leaves tend to be a very distinct yellow color. Not only can leaves be adversely affected by exposure to growth regulator herbicides, so can flowers. This is an example of a rose that was exposed to 2,4-D, and you look at that flower and lots of folks can't really tell that it's a rose. You can get a sense that this really is a rose. If you look in the upper middle, you can actually see a new flower bud that's beginning to form. That looks characteristic like a rose flower bud, but certainly the flower that's open looks very, very bizarre. The good thing about these sorts of herbicide exposures is that it's typically only the plant parts that are being formed at the time of the exposure that will look really odd. Any plant part that is produced after the exposure typically will look normal. So plants can outgrow this sort of damage. Sometimes pesticide issues are not due to herbicides but are due to fungicides, and this is somewhat ironic because you are supposed to be applying fungicides to help prevent disease issues. In this particular case, we had a greenhouse grower who was growing geraniums. The grower was very concerned about having a root rot problem and decided to use a product called Banrot. Banrot is a great product for controlling root rots in greenhouse grown plants. What happened in this situation, though, was that the grower, instead of applying the product at the labeled rate, applied it at 4 times the label rate. And so at that concentration, the product became toxic and he ended up with all of this necrosis or death around the edge of the leaves, and actually ended up with plants that were less healthy than if he had had a root rot problem. Air pollutants can also cause plant damage. This is an example of sulfur dioxide damage on a Schefflera. Sulfur dioxide tends to be produced wherever coal is burned, so we tend to see more damage of this type in the vicinity of plants that burn coal as a fuel source. In this particular example, I look at these symptoms and to me they really scream that this is not a disease problem. In the lower leaf you see a lot of flecking in the tissue, those kind of gold flecks. You might misidentify that as a mosaic symptom associated with a viral infection, but really that top leaf with a very marginal, very bronze sort of look to the dead tissue is really a sort of symptom that I don't associate with true diseases. Again, when I see very uniform symptoms around the margins of leaves, that's usually a clue to me that I'm dealing with some sort of non-biological cause to the problem. Another example of an air pollutant causing a problem, in this particular case, fluorine gas. Fluorine gas is typically produced in areas where there's a lot of manufacture of glass, and it is absorbed by the plants through the stomates. It tends to concentrate around the margins of the leaves where it causes some problems. What I'm looking at when I look at this particular photo that kind of, again, clues me in that we're not dealing with a true disease but some sort of abiotic factor is the fact that the symptoms are pretty much marginal. They're around the edges of the leaves. Again, disease-causing organisms typically don't form that uniform of a symptom pattern. The other thing that I see is this very odd-looking necrosis. It almost looks as though that dead tissue is like cellophane, and this isn't the sort of characteristic that I associate with necrotic tissue that's been produced by some sort of plant pathogen. Sometimes chemical damage to plants can have a biological origin. In this situation, an arborvitae with a relatively localized cluster of brown needles near the base of the shrub. Can you guess what might have caused this? If you're thought that this is due to a dog, you're very correct. This is urea or urine damage. We oftentimes see this on arborvitaes or other types of shrubs where there happens to be a dog in a household. If you see this sort of pattern, always question a client about whether or not they have a dog or whether there might be neighborhood dogs that might visit that particular shrub. Extreme weather conditions can also lead to plant injuries. One of the most common weather-related injuries that we see in plants is cold injury, in this case shown on a spruce tree. There's a bit of irony here because typically we think of conifers or evergreens as being very, very cold tolerant, but in the case of spruces, they can be very sensitive to cold temperatures just as the new growth is beginning to emerge in the spring, and that's what happened in this situation. The tree began to push its new shoots or candles. There was a cold snap, very cold temperatures, and that led to death of virtually every growing point on this particular tree. On the other end of the temperature spectrum, high temperatures can also cause problems. In this case, American ginseng that is experiencing heat injury. American ginseng is a native plant in Wisconsin. It grows naturally in wood understories. It's also grown commercially, and the roots are harvested for export to China. It's typically grown under shade to keep it cool and to keep the light levels down. But this particular photo was taken in 1988, which was an extremely hot and very dry year in Wisconsin. And all of the kind of cellophane-y brown tannish tissue that you can see on the leaves of these plants is due to excessive heat. The plants are very, very sensitive. Ironically, if I were to see this sort of injury much earlier in the growing season, this particular photo was taken in July, but if I would see this injury in, say, April, then I would be more suspicious of something like cold injury, because frost injury on ginseng produces very, very similar symptoms. And then there are a variety of problems related to water availability in plants. One of the most common water stress issues that we tend to see in conifers in the spring is something called winter injury or winter kill. I probably see this most commonly on yews, which is what is shown here. And this is basically due to the plants dehydrating over the wintertime. In this case, I suspect that there was a layer of snow on the ground up to the bottom of where you see the brown needles on the shrub. There was probably a cap of snow on the top of the shrub, and those needles that are now brown were likely exposed to the air. I suspect we got a nice warm day so that those needles started to transpire, that is, naturally lose moisture through the needles. But the root system of the shrubs were not warm enough to be able to take up sufficient water to replenish the water that was being lost through the needles, and that led to a dying of the needles in that exposed area. The best way to deal with this problem is to make sure that conifers and other types of evergreens are watered adequately in the fall. I normally recommend that these sorts of trees and shrubs receive about an inch of water per week, either from natural rain or supplemental watering, all the way up to the point when either we get a significant snowfall or the ground freezes. Water stress can also occur during the summertime if we don't get significant rainfalls and if we're not watering trees and shrubs and other types of plants adequately. One of the most common symptoms that I see related to water stress on things like conifers, particularly spruces, is a purpling of the needles, typically at the tips of the branches or the top of the tree, working its way down or in, and this purpling can eventually progress to a browning and death of the needles. Again, the best way to overcome this sort of problem is to make sure that trees and shrubs are getting adequate water. Again, about an inch of water per week, either from natural rain or from supplemental watering.